Question number 21. Diagram shows a ray of light in glass. The ray reaches a boundary with air. One weak ray of light is missing from the diagram. One weak ray of light missing from the diagram. Which statement is correct? Which statement is correct? At the boundary, the speed of light will become less. That is wrong. It remains same at the boundary. The critical angle for light at this boundary is 50 degree. That is wrong. Critical angle will be here. That is the angle of incidence where it is 40 degree. This is also wrong. Abhishek said D. Okay. The third, the diagram shows an example of diffraction of light. This is not a diffraction of light. This is a refraction of light. In the fourth option, the missing ray is a weak reflected ray. Yes, we can say that somewhere angle of incident is 40 degree. So some part of the light will reflect with the same angle of I 40 degree. And so that is the meaning of this question. The right answer is D. Question number 22. Nowadays, many students are asking solutions of this kind of questions. So listen carefully for the best explanation for question number 22. Light traveling in air enters a plastic block. It may be plastic block, it may be a glass block, children. Whatever the thing is given in the exam. Angle of incidence of 62 degree is given. Angle, first thing children always remember, angle I is a angle between what? Incident ray, this is the incident ray, and the normal, this is the normal dotted line, children. So this angle is given 62 degree. The plastic has a refractive index 1.48. The plastic material. What is the angle of refraction? Whenever you have to find, children, this angle of incidence or angle of refraction, you have to use a Snell's law. Apply the Snell's law at point this. Suppose this is the point where the light incident, uh, this point P, and Snell's law, here you have to use N1 sine I equal to N2 sine R. Always remember to use this equation. N1 sine I equal to N2 sine R. What is this N1 here? N1 is basically from where the light is coming. Light is traveling from the first medium, that is the rarer medium. So you need to put the refractive index of that value. And we know for the air, refractive index is 1. So N1 is equal to 1 multiplied by sin or sine of angle I is incidence, which is 62 degree, equal to N2. N2 means that in what medium that the light entered after refraction. So light basically entered into the second medium, which is a denser medium, and that is a plastic, and whose refractive index in the question is already given, which is 1.48, multiplied by sine R. That R you have to calculate. So you need to use your calculator. So first you need to find out the value of sine 62. Then 1.48 you can put here in the denominator, and in the right hand side we have sine R. And then finally, after finding the value of sine 62 divided by 1.48, whatever the result will be here, then finally R is equal to sine inverse. All these things you have to do in calculator, and sine inverse whatever the value you have got here. Now, children, may I know that two students have sent their answer. Yesh said it is C, and no, sorry, yeah, Yash answer is C, and Abhishek answer is also C, and 37 is the answer. Sometimes children in exam, I don't know that after doing the calculation what answer is coming. It may be 36 point something. It may be 36 point something. Sometimes it is 37 point something. So you have to see the nearest answer. So nearest answer will be around 36 or 37 point something is 37. Callister, because N1, the refractive index of air is always 1. Okay. Next question, children. Question number 23rd. A sound wave travels from a medium in one state into the same medium, but in another state. This caused the speed of the wave to change from approximately 300 meter per second to approximately 3000 meter per second. And between which two states is the sound wave is traveling? Sound wave, they are talking about the sound wave, which is a longitudinal wave. And 300 meter per second, children, we have practiced such kind of question in the last time also. Speed of sound in air is in between 300 to 360 meter per second. So this value, this sound travel with this speed in air, is the speed of sound in air, and then it reached to the value of 3000 meter per second. 3000 is a very high value for the speed of sound, and the speed of sound is maximum in solid. So it means that 3000 is something related to the speed of sound in a very denser medium, that is a solid. So air and solid combination you have to find out. Gas to solid, liquid to gas is not, liquid to solid is not, because in a liquid also the speed will be around 1000, 1000, 1500. So solid to liquid is wrong. A is the answer for this question, children. Yes, your answer is correct. A. Question number 24. The moon is at a distance of 380,000 kilometers from the earth. A laser light beam is directed from the earth to the moon. The beam is reflected back to the earth. How long does it take for the light to travel to the moon and back to the earth? How much time it will take? You need to calculate time, children. And question is simple, but you have to be very careful in this question. Time you need to calculate. As you know, the equation for time period, time is given by as speed equal to distance upon time, then time equal to distance traveled by the laser light divided by speed of laser beam or laser light. So distance, how much distance is traveled by the light? So let me draw a diagram actually. Moon, surface of earth, a laser beam is going traveling to a distance of 380,000 kilometer, and then return back to the surface of earth. So the total distance traveled by the light would be 2 multiplied by 380 and 1230 kilometer. This is in kilometer. I need to convert it into meter. So I will multiply it by 1000, turning kilometer into meter. Speed of laser beam produce, what kind of light, children? It travel with the speed of light. So that, and the speed of light value I know, 3 times 10 to the power 8. 3 times. Now, children, you have to divide it and then tell me your answer. Do this calculation in calculator. Yash said D. I need the answer from 2, 3 students so that I can check. Yash said D. Please do calculate in calculator. I'm not doing this calculation in my calculator. Please do yourself. Is it? Abhishek is saying B. Millisecond is not possible, I think. Abhi. No, no. Either C or D. Please check. Ethan said 2.53. Okay. Most of the students are saying D, 2.53 C. And let me check in the marking. Yes, answer is 2.53 seconds. But do you have to remember, you need to multiply the distance should be doubled because the light is going upward and then coming back. They said, how long does it take for the light to travel to the moon and back to the earth? So the distance should be added, both the distances. Distance in one direction, then in the other direction. Correct answer is correct. 25. Which statement about radio waves is correct? Radio waves are the electromagnetic waves. They travel with the speed of light. So, okay. Such information is not in the options. They are used in TV remote controls. If you have read carefully that the electromagnetic spectrum's properties, all of the radiations where this kind of radiations ray is used, so then you find children for television remote controls infrared radiations are used, IF rays are used. Option A is wrong. They can be detected by the human eye that we can't detect. We can only see the visible light, and with the help of the visible light we can see the objects. They travel as longitudinal waves. No, electromagnetic waves are transverse wave. These are not the longitudinal wave. Longitudinal wave is sound wave. C is also wrong. They have the speed in vacuum as ultraviolet waves, UV waves, as well as what radio, because all they are the part of the electromagnetic spectrum and they travel. All of them travel with the same speed. Question number 26. Diagram shows the Earth and its surroundings. Through which labeled region can sound not be transmitted? Sound, I think without it's a very simple question. Sound cannot travel in vacuum. If vacuum is there, then sound cannot travel. So if you see the diagram here, sea water, sound will travel in water better than air. Land rock, speed will be highest. Atmosphere of air, that it will pass. But in option D, that the outer space of vacuum, in outer space for the sound as a longitudinal wave, it require a medium for its propagation. So question number 26 answer is D, fourth option. Different waves travel through air. Hmm. Different waves travel through air, children. Which waves have the greatest difference in speed? Okay, difference in speed. You have to calculate. And ultrasound means UV and sound wave. Okay. UV are the electromagnetic waves and sound wave the sound wave. I think that the option can be correct. Ultrasound wave. So sorry. This is ultrasound. Okay, sorry. Ultrasound. I thought it's ultraviolet. Ultrasound is different. So there is not a big difference between ultrasound and sound wave. Option A is the possible the wrong answer. Ultrasound wave and ultraviolet ray waves. Okay, maybe let me go to the option C also. Ultraviolet, UV, and light wave they have the same speed. Wrong. Ultraviolet, UV, and radio they also have the same speed. This is also wrong. And ultrasound and sound wave there is not a big difference between them. Option B, children. Ultrasound that we can't hear, and the ultraviolet that the electromagnetic waves. So question number 27 answer is no, Abhishek, you said D. D is wrong. Ethan answer is correct. He said the B. Yash also said B. Correct. Question number 28. In 28, a train of steel nails and a train of irons hang from a strong magnet. The trains are then carefully removed from the magnet. Trains are removed, okay, very carefully they are removed, separated from the magnet. They are in contact, these trains are in contact with a magnet, strong magnet, a powerful magnet. What happens to the trains when they are removed carefully? Steel nails, iron nails. Now, children, here you have to use the concept of for making a permanent magnet, we prefer steel. Steel, once it is difficult to magnetize steel, but once it get magnetized, it take very longer period of time to demagnetize it, or its retentivity is higher. It can retain a magnetism for a longer period of time as compared to iron. So I think from this explanation, you will be able to find the answer for question number 28. And for question number 28, in this way, uh, what the trains are then carefully removed from the magnet. What happens to the trains? Both train stays together? No, because ions will lose its magnetism immediately, and then these nails will fall down. Only the train of iron nails falls apart. Only the train of steel nails falls. No. In D, cannot be possible. Both trains fall apart. No. A is wrong. Both trains stay together. That's wrong. C. I'm getting C. What is your answer, children? For question number 28, I want to see in the marking scheme also that it states it is 28. Answer is C. Yes, yes. Good. All of you, please, the entire 10th class. And then I'm not getting answer from you. You have to listen to me and you have to keep doing these questions. Yabin, Madeline, Natalia, Krish, Kanadika, no response. Melvin, keep sending your answer, children. Good, Ananya. But okay, you also keep sending your answers. What is the best method to demagnetize a steel rod? Best method, as per the options given, pass the rod through a coil connected to an AC supply. AC supply, yes. AC current demagnetize the magnetized rod. Pass the rod through a coil connected to, no, DC will help to magnetize it. Place the rod next to another magnet, no. Stop the rod with another magnet, no. So as for the four options given, children, that the best possible answer you can find, you and me can find, that is option A. Option A, children. Pass the rod through the alternating current. Callista's answer is A. Yabin answer is A. Question number 30. In question number 13, the question is there is a current in a metal wire, and then which particle in the wire moves to cause the current? What particle? Current flow in the conductor due to the presence of free electrons. So free electrons in question number 30, answer is B, electrons. The diagram shows a circuit with a gap between points P and Q. Four pieces of metal wire of the same material are connected in turn between points P and Q in the circuit. The table gives the diameters and length of the wires, in which wire the current is the largest. Current largest, children. So diameter is given, length is given. What method, what equation you will apply here? You need to find out the current, maximum current. So if you need to find the maximum current, children, you need to use this equation R equal to L upon A, basically. Okay, R is proportional to length and R is inverse proportional to the area. And they said if we need high current, so current will be higher if resistance is minimum. So you have to find out the how we can reduce this resistance so that the current will be maximum. To reduce the resistance, I need to reduce the length. I need to reduce the length, children. So I need to reduce the length, so length should be very small. And so it means either the option A or D will be correct. And what about the area? To reduce the resistance, I need to increase the area because R and A are inverse proportional. Area is something related with the diameter. Okay, children. And so area should be increased, and increased. Which combination will be? I need less length. I need higher diameter. Should I go with A or C, children? Now you can check. I need higher diameter and lesser length. So I think this combination means 0.20, this one. 0.20 and 1.0. C is the right answer. Let me see your answers, children. Yash said 31st C. Calista said 31st C. Gabriela said 31st C. Natalia also said C. Good, Natalia. Okay. It is C. Question number next. 32. A battery is connected to a circuit. It is switched on for 1 minute. During that time, there is a current of 0.40 ampere in the circuit, and the battery supply a total of 42 joule of energy. Which row gives the charge that passes and the electromotive force of the battery? Try, children, this question, all of you, looking a little bit trickier. You need to do this question carefully. It is switched on for a time period of 1 minute. Hmm, 1 minute time. Current is flowing 1.40 ampere. Battery supplies this amount of energy. Which row gives the charge that passes and EMF? If I start to calculate the EMF, can I use this equation E is equal to children VIT? If you are know this equation in electricity chapter, E is equal to energy is VIT, voltage is we need to calculate. So V is equal to energy divided by current and time. Let me just find out the value of V first. Energy given 48 joule. Current I can take 0.40 and multiplied by time is 1 minute, should be converted into seconds. So 1 into 60, 60 I will write here. Please someone divide this value. Please solve it. Let me do it in traditional.
That's two.
2.
True,
Okay.
sir.
So this 0 cancel out. This 0 cancel out. 4 ones of this will be 12. Then 6 to the 12. Yeah. 2 volt. So 2 volt I can see here, and 2 volt I can see here. So the it means D you have to remove. A sorry, and B you have to remove. Now you have to put efforts on A and C. Charges that pass through 1 minute, children. Q. So what equation you will apply to calculate I is equal to, in a very very simple equation, I is equal to Q by T. To calculate the Q, I think that better to use this equation, I multiplied by time. Current is that the same current again, 0.40. Time is what again, 60 second, need to convert into second, 60 second. Please someone multiply this value. 6 for the 24 will be 24.
24.
It is the 24. So the answer is here C. C is the right answer, children. Coulomb. Unit is given coulomb and Q charge in coulomb when you take current in ampere and time in seconds. So that's why we need to convert this time 1 minute into seconds also. Ethan's answer is correct. Abhishek answer is also good. 32C. Let's move to the next question, children. And we have still 9 minutes before this meeting end. 9 minutes. Let's try to do the remaining 7 question. 8 question. Identical cells and identical resistors are used to make the circuit shown in the diagram. And in circuit 1, the ammeter reads 2 ampere. What is the ammeter reading in circuit 2? Hmm. In circuit 1, ammeter reading is 2. What is the ammeter reading in the circuit 2? Oh my god. 33C is wrong answer, children. And I think many students will say it is C. C is wrong. Need to read this statement carefully. Identical cells, 33B said wrong. Identical cells, identical resistors are used to make the circuit shown. Ananya said A is wrong, A wrong, B wrong, C wrong. But in this question, I will take some time to explain this question. I don't have any shortcut method of doing this question, children, but I will do a method that all of you can understand, and I am doing it. I'm using it. If you have a shortcut method, children, then you can also explain it to me. You can share your explanation in the chat box, children. So they said the current here, sorry, is 2 ampere. Battery, suppose it is a V volt, and in the other side this will be twice of volt because the two cells are there. And this resistance suppose R, then this is also R. They have set the identical resistors, but in the second circuit they are connected in parallel. In parallel, what happens? Overall resistance decreases, current should be increased. So current should be increased, then the option A is completely wrong, and B also becomes wrong. So your answer will be either from C or D. Then we have to find out the right answer by using a concept of electricity. And so children, V equal to IR, that is the from the Ohm's law equation. V is equal to I into R. I can write here that V equal to current is 2 and the value of this R is R because it is not given. Let me write this R equation number 1. So this is the we have done the left circuit. We have solved the left circuit diagram, voltage. Come to the second circuit diagram. In the second circuit diagram, both the resistors are in parallel. So I need to calculate how much current is there in the second circuit. So what is the equation basically? To find the total current, we know that the total voltage of the second circuit, that is 2. Let me write 2. Okay, children, and divided by I is equal to V, voltage divided by resistance. So the resistance of the second circuit will be, let me first find the resistance. RP equal to R into R and divided by R plus. So this is equal to R square divided by 2R. One of the R cancel out. So a resistance I'm getting R by 2. That is the total resistance in the combination. So R by 2. So R will be here, 2 will be here. So I got this I is equal to 2 to the 4 into V upon R. Can I use the equation 1 here? From the equation 1, 4 multiplied by V. V is from the equation 1, that is multiplied by R, and divided by R. I can cancel R here. So I got the current in the second circuit, that is 4 to the 8, 8 ampere. I don't have a shortcut method, children. That the long explanation, but if you have anyone have the shortcut method, you can also apply it here. Now, sorry, let me just keep it here for more time. You want to take a snapshot, please take it. A, B, C all are wrong. That's the right answer, children. D, delta. Question number 34. The diagram shows a circuit with a fixed resistor. Fixed resistor is then connected in series with a thermistor. Yeah, thermistor is there. Now you can remember, if you don't know, children, how to draw a thermistor, look at the diagram. Thermistor is there and ammeter is there. Which row shows how temperature change affects the resistance of the thermistor and and uh, and the current in the circuit? How temperature change affect the of the thermistor resistance of the thermistor and the current in the circuit, overall current in the circuit, children. How will you do this question? So for this question, children, you should know the relation between resistance of thermistor and temperature. And resistance of thermistor is inverse proportional with temperature in case of thermistor. That you have to remember this value. If you don't know, please remember. Resistance is inverse proportional with thermistor. In case of a conductor, metals, conductor, resistance is proportional with the temperature. But thermistor, it is reciprocal of inverse proportional with the temperature. So that inverse proportion, that if the temperature will increase, then the resistance will decrease, and if the resistance is decreasing, so current will increase. So let us find out. But I will start from the option A. Suppose they said the temperature decrease. If I decrease the temperature as per this option A, let me use the yellow in here. If I decrease the temperature, then I know that the resistance of the thermistor will increase, but they are saying it is decreasing. So A is wrong. Let me move to the option B. In option B, they said temperature is decreasing. Okay. Resistance of thermistor will increase. Yes, it is increasing. What about the current? If resistance increases, so current will increase or decrease, children? Resistance will increase, current will decrease. Yeah, I think I found the right answer B, but I want to go to the option C also. In option C, they said if I increase temperature, okay, if I am increasing temperature, now let me use the different ink here. If I increase the temperature, okay, increase the temperature, decrease the resistance, Yes, resistance will decrease. What about the current? If the resistance is decreasing, current will increase. So this pair is wrong. This part is wrong. Similarly, the D also wrong. And let me confirm from the marking scheme also 34 and the right answer is B. Yes, children. I hope you got this explanation. Ethan said B. Yes, Ethan. And let me move to the next question. 35. Logic gate questions are simple, children. I'm not doing this question. You can practice by yourself. And question number 36. The diagram shows a short circuited copper coil swing about an axis at right angles to a strong magnetic field. The motion induced a current in the coil. Motion induces a current in a coil. Okay, then what we have to find? What is the effect, if any, of this induced current in the coil? Short circuit copper coil swinging about an axis at right angle to a magnetic field. Okay, right angle to a magnetic field. Motion induces a current in the coil. And what is the effect, if any, of this induced current in the coil? Coil is rotating in the magnetic field. It is crossing the magnetic field, and then due to that, magnetic flux will change, current will induced, and the current will induce. They already said the current is there. So what happens then, children? Current will induce that. It will also create. It will generate a magnetic field. That the magnetic field. What happens, children? The induced current has no effect on the movement of the coil because copper is no, option A is wrong. The induced current produces a magnetic field of constant magnitude in the coil, not a constant magnitude in the coil. It keeps changing as it is oscillating. The induced current produces a forces that assist the change causing it. Induced current produces a force. Force will be generated, children. Force will be induced, but won't assist. This is as per the Lange's law. The induced current produces the forces that opposes the change. Who created it? Who is causing it? So you need to study the Lange's law, children. Lange's law is there in your textbook. So for that, the question answer is D. Few seconds left, children. That I think we will be able to complete the question. And 37, let's see that we can complete it. Diagram shows a magnet being pushed into a coil that is connected to a center zero galvanometer. Initially, the magnet is away from the, means outside the coil, and then see the